Good afternoon, my name's Dr. Pearce. I'm from the Cotswold School in Bolton-on-the-Water. Today I'm going to be going through the first question of the GCSE Chemistry paper for 2023, paper 1. Reason I'm doing this is so that our students are able to assess it, and if they have any questions to use it or contact me. I'm going to be going through each question at a time, so this video is just for question 1, and I'll be putting up videos of question 2, 3, etc. So let's start off with question 1. It says discoveries in chemistry led to a better understanding of atomic structure. Atoms were originally thought to be tiny spheres that could not be divided. The plum pudding model of the atom then developed, and figure 1 represents the plum pudding model of the atom. And it says describe the plum pudding model of the atom. So really what we're asking you to do here is just to describe the atom. I can see that I've got two parts to this. I've got this big ball of positive charge. And then I have negative charges embedded in it. Now, obviously, I would normally write that there, but it does just go to show all you're doing is describing the diagram. Of course, negative charges there represent the electrons. Positive charges, they didn't know about protons at the time and the nucleus, which is why it's quite an early model of the atom. Atoms contain electrons, neutrons and protons. Write these particles in order of their discovery. Now, as we've seen above, they knew about electrons quite early. And in fact, electrons were the first subatomic particle that were discovered. And the main thing is they're very, very easy to remove. The next thing that was discovered was the positive protons. And the reason why they were discovered is because they're charged, so it's actually quite easy to detect charged things. The last thing that was discovered was the neutrons. By the way, I do apologise about my handwriting. I'm not particularly used to using one of these things here. So few atomic atoms of the element tennessine have been identified, and tennessine has an atomic number of 117. So tennessine 117. Now, what we can see is that tennessine even, is just below astatine, which is just below iodine, bromine, chlorine and fluorine. So we can see that this is in group 7. So if we looked at the periodic table, we'd see it is in group 7. So because it's in group 7, that tells us our number of outer shell electrons. And indeed, that is the reason, because it is in group 7. Okay, so tennessine was first discovered by a small group of scientists in 2010. So this is a small group of scientists. It's just one reason why tennessine was not accepted as a new element by new scientists, other scientists, until 2015. The reason for that is because it's not been checked or verified by other people. They might have already known about it, but there has to be a process by which they check the science, and that's called peer review, and that takes time. So it hadn't been peer reviewed until then. Now, what peer review is it gets sent off to another bunch of scientists. They can either redo the work or they look at the work and go, okay, yeah, the evidence points to that. The whole idea about science is it's not just something we make up in isolation. Science, when it's properly published, is looked at by other people, it's repeated by other people, so that we know that we've got the science right. Now, let's move on to question 1.5. Here we have Element R, which has 2 isotopes. Remember, isotopes are the different numbers of neutrons, because the number of protons tells us the type of element that it's going to be, but the neutrons, different neutrons, are different isotopes of the same element. I can see the mass number, and we know the mass number is the neutron number plus the proton number. We have 100, say, atoms here, because it adds up to 100%, and we've got mass number of 6 and 7. So what we're trying to work out is how what the average mass of one of these atoms is. And we can see it's a percentage, and we know that all our percentages add up to 100. So if I go 6 multiplied by 7.6 plus 7 multiplied by 92.4. And what I'm going to do, so that it's an average and there's 100 atoms, we go for divide by 100. And that's going to give us an answer of 6.924. Now, something else that's on here, it says it gives the answer to 1 decimal place. And it's really important you give it to 1 decimal place, because if you don't, you lose a mark. So this to 1 decimal place is going to be 6.9. Pretty easy. Now, little tip for you. If you don't know the answer and you really don't have a clue, in quite a lot of these questions, they do have this thing that says that if you use all your data in a calculation and you give an answer to 1 decimal place, we give you 1 mark for that. So if you really don't know what you're doing with any of these questions, when they say give it to 1 decimal place or 2 significant figures or something like that, use all the data and put the answer to the correct amount of significant figures, and quite often you'll get 1 of the marks for it. So that's the end of question 1, and I'll do a video for question 2 shortly.